Good afternoon. So today we are going to conduct next experiment in our Electrical Machines 2 course. The title of the experiment is V curves and inverted V curves of three-phase synchronous motor. The aim is to study the effect of variation of excitation on the performance of three-phase synchronous motor at constant load. Now here while performing the experiment we are actually not connecting any load, so we can get this V and inverted V curves at no load condition also. So we are going to conduct right now at no load condition. So let us see the circuit diagram for this particular experiment. Now this is our circuit diagram of the experiment. So we are giving three-phase supply with the help of this three-phase thermostat to the armature of the three-phase synchronous motor, which is star connected. So in order to measure the input power, we are using 2 wattmeter method. So one wattmeter is connected in R phase and second wattmeter is connected in Y phase. Then one ammeter is connected in R phase. After that switch is there, and across the switch 0 to 1 ampere ammeter is connected across that. This switch is normally on condition. So whenever the current drawn by the motor getting less than 1 ampere, at that time we can make this switch off, so that below 1 ampere current can be measured by this ammeter. Then voltmeter will be connected across R and Y phase to measure the input voltage. As far as rotor field is concerned, we are exciting it with the help of 220 volt DC supply. There we are using 2 rheostats, 600 ohm 1.7 ampere and 200 ohm 2.8 ampere rheostat in series fashion, and then one switch is there in series with that. And then in the field circuit again we are using one ammeter 0, 1, 2 ampere capacity in order to measure the field current of the motor. So this is in all the complete circuit diagram of the experiment V and inverted V curves of synchronous motor. Now let us see the connections. Let us see the connections for this experiment. Now as per the circuit diagram, we want to take three-phase supply. So we are taking three-phase supply from here RYB. This three-phase supply can be made on by using this 3-pole MCB which is provided here. Okay, now this RYB three-phase supply is given as input to this three-phase thermostat. So this RYB 3 wires are coming to this input side, RYB of the thermostat, here R, then Y and then B. And then from the output of thermostat RYB, our actual connections to the synchronous motor will begin. So from first R phase, as per the circuit diagram, this R phase is initially connected to wattmeter 1 M terminal. Then M and C of wattmeter 1 is shorted. Then from L of that wattmeter it is connected to ammeter common. Then ammeter 10 ampere will be connected to the switch. Okay. Then the second terminal of switch will go to the R phase, and across this particular switch we have connected AC ammeter of 0 to 1 ampere capacity. Okay. So this switch is normally in 0 to 1 ampere 0 to 1 ampere capacity, right? Now this switch is normally in the on position. This switch is normally in the on position. Okay, so that initially the ammeter will be bypassed and the current will be measured by the ammeter of 0 to 10 ampere capacity, right? So this is R phase. Then for Y phase, the Y phase from the thermostat is coming to the second wattmeter M. Then second wattmeter M and C is shorted, and from its L it is directly going to the Y terminal of the winding, star connected winding of motor, right? Then B phase is directly connected to the B phase of synchronous motor, right? And then the pressure coil terminal of wattmeter 1, that is here 600 volts. Here you can see it is connected to 600 volts, right? and pressure coil terminal of second wattmeter, that is 600 volts. These two wires are taken and they are connected to the third phase, that is to the Y phase here. So in this way the connections for the armature of the synchronous motor are completed. Right? Now coming to the excitation part. Now for the excitation part we are taking DC supply, 220 volt DC supply from the table from here, and for this the MCB is provided here to switch on the supply. We are using this 2-pole MCB. Then from positive of this DC supply it is connected to the rheostat fixed, first rheostat fixed, and the second terminal of rheostat is connected to the second rheostat fixed, and from fixed terminal of second rheostat it is, as per the circuit diagram, it is coming to the switch. Okay, so here again switch is there, single pole switch is there, and then second terminal of switch is going to the F1, that is the field winding of the motor, and then F2 will come and that is connected to the ammeter positive terminal to measure the field current, and then from ammeter negative, that is 1 ampere, it will go back to supply, that is negative terminal. So in this way the connections for the excitation circuit or the field circuit of the synchronous motors are completed. Okay, so thank you.